Mercury is the smallest planet in our solar system, located closest to the Sun. It has fascinated scientists and astronomers for centuries with its unique characteristics and has been the subject of numerous space missions. In this video, we will explore the basic features of Mercury, including its size, surface temperature, and position in the solar system. Mercury is the smallest planet in the solar system, with a diameter of only 4,880 kilometers. To put this into perspective, Mercury's size is approximately one-third the size of Earth and just slightly larger than the Moon. Despite its small size, Mercury has a mass that is about 5.5% of Earth's mass. Mercury is the closest planet to the Sun and orbits it in just 88 Earth days. Its distance from the Sun varies greatly, as it follows an elliptical orbit. At its closest approach, Mercury is only about 46 million kilometers away from the Sun, while at its farthest point, it can be up to 70 million kilometers away. Mercury's proximity to the Sun means that it is exposed to extremely high temperatures. The planet's surface temperature can reach up to 427 degrees Celsius during the day, while at night, temperatures can drop as low as -173 degrees Celsius. These extreme temperature variations are due to Mercury's lack of atmosphere, which makes it unable to retain heat. Mercury's surface is heavily cratered, similar to the Moon's surface. The planet has numerous impact craters, some of which are over 1,000 kilometers in diameter. There are also many other surface features, such as mountains, valleys, and plains, that have been formed by tectonic activity. Mercury has an extremely thin atmosphere, with a pressure that is about 10 trillion times less than that of Earth's atmosphere. The planet's atmosphere is composed mainly of helium and hydrogen, along with small amounts of oxygen, sodium, and potassium. Due to its thin atmosphere, Mercury is unable to retain heat, leading to its extreme temperature variations. Despite its small size, Mercury has a magnetic field that is about 1% as strong as Earth's magnetic field. This magnetic field is believed to be generated by the planet's core, which is composed mainly of iron. The magnetic field helps to protect Mercury from the solar wind, which is a stream of charged particles emitted by the Sun. Mercury, like other planets in our solar system, is believed to have formed from the dust and gas that surrounded the Sun in its early days. The current theory suggests that a large object, such as a planetesimal, collided with the young Mercury and stripped away much of its outer layers, leaving behind a dense core. This core is believed to be composed mainly of iron and nickel, and it is thought to make up about 60% of the planet's total mass. The remaining 40% of the mass is thought to be made up of a silicate mantle and a thin crust. Mercury's evolution is believed to have been shaped by a number of factors, including its proximity to the Sun, its small size, and its lack of atmosphere. One of the most significant factors is the planet's proximity to the Sun, which has led to a number of unique features. For example, Mercury's extreme temperature variations are caused by its lack of atmosphere, which means that it is unable to retain heat. The planet's surface can reach temperatures of up to 427 degrees Celsius during the day, while at night, temperatures can drop to -173 degrees Celsius. Another factor that has influenced Mercury's evolution is its small size. The planet's small size means that it cooled and solidified more quickly than other planets, and this has led to a number of unique geological features. One of the most distinctive features of Mercury's surface is the Colorus Basin, which is one of the largest impact craters in the solar system. This basin is over 1,500 kilometers in diameter and was formed by a massive impact early in the planet's history. Mercury's lack of an atmosphere has also played a significant role in the planet's geological features. For example, the planet has very little erosion, which means that many of its surface features have remained relatively unchanged since they were formed. The Mariner 10 mission was launched by NASA in 1973, and it was the first spacecraft to visit Mercury. The mission was designed to study the planet's atmosphere, surface, and magnetic field, and it was able to capture the first close-up images of the planet. The spacecraft flew past Mercury 3 times in total, with the first flyby taking place in 1974. During each flyby, Mariner 10 was able to capture detailed images and data of the planet, which provided scientists with valuable information about Mercury's geology and environment. One of the most significant discoveries of the Mariner 10 mission was the presence of a magnetic field on Mercury. This was unexpected, as the planet was previously believed to lack a magnetic field due to its small size and slow rotation. The discovery of a magnetic field on Mercury has allowed scientists to better understand the planet's interior and geology. The MESSENGER mission, which stands for Mercury Surface, Space Environment, Geochemistry, and Ranging, was launched in 2004 by NASA. The mission was designed to study Mercury's atmosphere, surface, and environment in greater detail than the Mariner 10 mission. The MESSENGER spacecraft arrived at Mercury in 2011 and spent 4 years studying the planet and its surroundings. During this time, the spacecraft was able to capture detailed images of the planet's surface, study its geology and chemistry, and measure its magnetic field and atmosphere. One of the most significant discoveries of the MESSENGER mission was the presence of water ice on Mercury's poles. This was unexpected, as the planet's surface temperatures are hot enough to melt most substances. The discovery of water ice on Mercury has raised questions about how it got there and what other surprises the planet may hold. Another important finding of the MESSENGER mission was the confirmation of Mercury's volcanic activity. The spacecraft was able to capture detailed images of volcanic features on the planet's surface, providing scientists with new insights into the planet's geology and history. Now we will explore the BepiColombo mission and other plans for future exploration of Mercury. The BepiColombo mission is a joint project between the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. The mission was launched in 2018 and is expected to arrive at Mercury in 2025. The BepiColombo mission consists of 2 spacecraft, the Mercury Planetary Orbiter, MPO, and the Mercury Magnetospheric Orbiter, MMO. The MPO will study Mercury's surface, composition, and geology, while the MMO will study the planet's magnetic field and its interaction with the solar wind. One of the key objectives of the BepiColombo mission is to study Mercury's interior structure and composition. The spacecraft will use a range of instruments, including a laser altimeter, to study the planet's surface and determine its topography, as well as a magnetometer to measure its magnetic field. In addition to the BepiColombo mission, there are a number of other proposed missions to Mercury that are currently under consideration. One such mission is the Mercury Polar Mission, which would study the planet's north and south poles. Another proposed mission is the Mercury Geology and Geochemistry Explorer, MAGE, which would study the planet's surface and geology in more detail. The MAGE mission would use a range of instruments, including a spectrometer and a camera, to study the planet's composition and geological features. There are also plans to send a lander to Mercury in the future. The European Space Agency has proposed a mission called MELISSA, Mercury Exploration Lander with in-situ sample analysis, which would involve landing a spacecraft on the planet's surface and collecting samples for analysis. These future missions to Mercury have the potential to make a number of important discoveries about the planet and its history. For example, they could shed light on how Mercury was formed and how it has evolved over time. One of the key questions that scientists hope to answer is why Mercury has such a high density compared to other planets in the solar system. The BepiColombo mission, in particular, has the potential to provide valuable insights into Mercury's interior structure and composition. The future missions could also provide new information about the planet's geological features, such as its craters and mountain ranges. By studying these features in more detail, scientists could gain a better understanding of the planet's history and how it has been shaped by geological processes. In conclusion, Mercury remains a fascinating and mysterious planet that has much to teach us about the history and evolution of our solar system. With the BepiColombo mission and other proposed missions, we have the opportunity to unlock new discoveries about this planet and gain a deeper understanding of its composition, geological features, and evolution over time. I encourage you to share this video with others who are interested in space exploration and to continue to follow developments in the exploration of Mercury. Thank you for watching.